Happy Monday, everybody. How's it going?
It's good. Happy Monday,
Good.
Joe. Welcome, Brian. Thanks for joining
Yeah.
us today.
What's up, Brian?
Yeah. I just swallowed my water the wrong way, so give me a second.
Okay, it happens.
Let's get on a good leg
Yeah.
here. Awesome. Cool. For people who don't know who you are, do you want to maybe give a quick intro?
Yeah, sure. So a lot of people who do know who I am know me from kind of being a developer advocate in the Trino community. And I worked just a month ago. I was working at a company called Starburst that is a vendor on top of that. Hey, look at that. So I did that for like 3 years. Got to know a lot of folks in the Trino community, as well as just the larger data community in general, and just learning what other thing. I before that, I guess I should back up just a sec. I was I was a software engineer that did data engineering work. So I worked on like the whole Hadoop Hive stack, and then got really fed up with that. Found out about Presto, and it was like the most incredible experience of my life, and just got really involved in that community there. And yeah, and then Starburst came along, offered the job, I didn't even know what developer advocate was, but yeah, so I do developer advocacy now. Just basically, and actually, you all had a kind of a meeting last week with Tim Berglund talking about what developer relations is and developer advocacy is. So I have yet to see it, but I'm excited to take a look at it. But yeah, so I do a lot of that type of work. If you did see that, and it's basically just filling in a lot of gaps where, especially open source communities can get really fragmented, and people coming in might want to like learn how to get started and either using the software, or sometimes it's just I want to contribute, and trying to lower the barrier for all of those things, for both contributor mentality and user mentality, and making that just a much better experience, developer experience. So I recently made a hop over into head of developer relations at Tabular, which is a company that is very close to my previous company, Starburst. And basically, we focus a lot on the building around the Apache Iceberg community. We have I won't go too far into the product, but it's basically Iceberg is a table format around like data lakes, and so we table format as opposed to a file format. We can get into that stuff later. It's not really the point of this talk today. The basic idea is that it's kind of an evolution of the old ways of Hive. As I was kind of saying, Trino's kind of the evolution of the Hive engine, and then Iceberg can be kind of like the progression of the Hive specification, or what I used to call the Hive specification. Now they're calling it table formats. I think Delta Lake is another one out there that has another way of calling it in their paper. But anyways, so that's where I kind of focus in now, is on the Iceberg space, and that actually opens up my world from just Trino to thinking about the different variations of Trino. So there's Starburst Galaxy, there's Athena, there's EMR, Trino, and then there's also, I think Microsoft might be getting in the game here shortly too on that end. But then there's Dremio is another query federation engine. There's Flink, there's Spark, of course, and so all of these different query engines, are things that can interact. Oh, and another big one, Snowflake and like BigQuery, right? They also can interact with Iceberg as well. And so having like this format that kind of can go across multiple query engines is kind of where my headspace is now. And so if you're interested in Iceberg, if you're interested in any of the ask questions about like query engines and stuff, I'm here to talk about that. But I want to talk about more broad set of things today. So that's a little background on me.
Yeah, I mean, the announcement of the show, we mentioned data virtualization. And so maybe you can explain a bit for our audience, really two concepts. One is data federation and the other is data virtualization. So like, what are those, and what's the difference between those two ideas?
And then
Yeah.
also, what are your hot takes after we're done
Yeah.
defining those
Like
things?
spicy
Curious,
takes. Yeah.
Yeah.
I'm unfortunately, I don't think I'm not a deliverer of spice, but I can bring a take anyways. And I don't think it's that spicy. I think it's just, it may be spicy for a couple people. I don't know. Anyways. So data virtualization is more or less this kind of basic concept of a pane. I like to just think of that pane of glass. I've heard somebody, reference this type of thing before, where you're separating, you're adding this layer of abstraction in between the people who are using the system. So like typically SQL users or analysts or BI people, right? And you're separating them from having to know about any of the internals. And so, like, if you have a single database, and that's pretty much done for you already, right? Like, of all of your data is in a single Postgres or piece right there, and that's like you're saying you're just starting your company, and everything that is as part of the company it lives there. Then, like, that's effectively like data virtualization. All the tables like all live in one location, and anything you do with that one database is reflected across every database in that entire company because it's a database of one. But we know we don't live in that kind of world. Like, it's obvious that we have different databases that meet different use cases, and then there's also acquisitions that happen that have a whole bunch of other slew of databases that met all of their use cases. And so we get into this like kind of like muddy mess of like crazy amounts of data. I'm just going to generalize it as a data platform where you just have, all sorts of shapes and sizes of databases that are solving different problems, adopted by different teams. And so you're never really going to be in the state of that perfect centralization. So data virtualization as a concept, when you expand it outside of just the one database, is being able to have a single pane of glass over all of those databases and separating your users from having to think about, well, what store does this thing belong to, what table, it's just all they really need to know is that, hey, let me go through and list some tables out of the information schema and I'm good. Like I know pretty much how to find things, right? Obviously it's not that simple. I'm very hand wavy at that point, but you're at least able to access that information. So getting people aware and figuring out how to actually find the data are actually looking for is a whole separate problem, but you're able to at least access that data. And that's what data virtualization is really trying to do. And access ideally in a uniform way. So that's very high level. It's not taking, so one thing I like to say that kind of differentiates, that people don't think about with data virtualization is like technically from a pure read-only aspect, right? Data warehouses are also kind of like a form of data virtualization, because data virtualization, while it requires you to be able to also update the data. But if you take out the whole writes and updates and all that kind of stuff and just focus on the read-only thing, that's effectively what a warehouse is doing for you. And so ETL everything from all these different places across the business org, and then you're kind of basically centralizing it into one place so that you can kind of get back to that picture that we had in the beginning with that single database. So you now are like, hey, all the things across the org gets there. I don't know if it's up to date. I don't know how it got there. I don't know all of this. I don't know if it's delayed or something's going down, but I do know that when I query, I have all of these tables that are supposed to be, something that I can get access to in my org. I know that they're all in one place. And so that's what a data warehouse, that's the whole point of a data warehouse, is kind of giving you that read-only data virtualization. So then we get into something, okay, well, a little more tangential. So we talked about, data warehouse. That's a read-only version of data virtualization. What about something that can do writes and updates and actually act like a database that is still multiple databases under the hood? This is where query federation or data federation comes into play. And so this is where you're not only just, trying to get snapshots and pull everything into one location and it's kind of like data warehouses are kind of eager. They're trying to like assume that you're going to use all this data and just snapshot it and get it all, copied over. Data federation, on the other hand, is trying to say, well, what if we just only pull data whenever we need it? What if we are going to basically just like, we'll push down, the queries to these different things, to these different, sub databases and things like that, and try to figure out a way to federate this query without moving everything all at once, and we'll go directly to the source, right? So, it doesn't even have to be directly to the source. You could actually have some sort of caching layers and stuff in between. So basically, query federation, data federation is trying to actually have a mechanism that you're going to give this one thing the query, just like data virtualization. And now, instead of not knowing anything about it, you're going to know a little bit about it. This virtualization, this federation layer has to be able to know about the internals of all of these different databases, because it has to know, hey, how do I find out the statistics for such and such columns on this Postgres database? How do I find out, where the splits, how to do the splits across this like data lake or this S3 set of S3 buckets, right? How do I respect those partitions? And so it has to know, this federation layer has to know a little bit about like all of these different data layouts, metadata, and all this thing, to really understand how to be an effective query engine layer, or how to be effective. I'm saying things specifically to Trino, and I'm trying to be a little more generic. How to be able to reason and do optimizations across all of these different data sources. And so this is basically the way I sum it up is that, data federation is a subset, just the same way that you could say that data warehousing fulfills a subset of data virtualization. Data federation is a maybe full-blown implementation or more concrete set of ideas around how to achieve data virtualization. So that's kind of my take on how to like separate those two concepts. One's kind of more umbrella term. The other one is a very much more specific, like you need to actually understand the internals of these things. And so one thing I'll get to now my I will pause to say if there's any questions before I move on to my hot takes. Or
what's your hot take, Brian?
Okay, sounds great. Let me just take a quick drink of water. I was hoping that was going to be a longer question.
You got to get warmed up for this. Yeah.
Exactly. All right, here it comes now. So my hot take is data virtualization's not a bad thing. It's like I know that's not crazy, right? But some people really don't think effectively data virtualization is kind of become this bad word. It's kind of become this or not a bad word, but it's like a word that nobody cares about anymore because it didn't work, did it? Yeah. So move on. We got to go back to centralizing everything, right? So I would actually say that data virtualization, and here's where the real hot take comes in. Data virtualization is actually going to be something that will dismantle a lot of this centralization movement, and ultimately put a lot of pressure on vendors who are aiming to get you into more of like just their storage platform, just their particular subsystem. And it's going to put pressure on them to actually have to make sure their product is meeting demands, to make sure that they are spending, that they're not charging, too much for their product. Because effectively what data virtualization is great in that it gives you the ability to see across all of these different systems when you have a mess of an architecture, right? You got all these other subsystems. That's the main thing people think about with data virtualization. But if you think about it, it also gives a lot of practitioners and users a huge leg up in the ability to effectively say, hey, well, if you don't do if you're not helping me out, I'm not stuck on your platform. In fact, I have, a version of the data moved over here. So I'm going to start, ingesting not only to you, but to this other system. And over time we'll roll out and like my current state of like in the next 3 months, I'll offload off of you. My virtualization is still the same single pane of glass that can see into my entire domain. So I'm not like the migration. Effectively, it makes migrating data a lot more kind of natural. You can move things around without your users being affected, and you're future proofing yourself by basically keeping where no user will be affected by you migrating to another competitor of that vendor, right? So I think that's really, I guess, the hot take you all were looking for. I don't think about it as a hot take. I think it's just like, I think in reality, I think it's just where we should be as a data industry to free us up from having to always have this like, no, migrate to this thing, no, migrate to this thing. I want there to be kind of a much more effectively move a lot more of the power to the consumer, and then keep things a little more distributed and even in the larger data space. And this gets into stuff with like, how do we do this with, and we'll get into data mesh and stuff like that in a little bit, because I think there's also a big piece that data mesh, even though data mesh is now on the like low end of the hype cycle now. So we hit the top of the hype cycle. Hold on. I actually brought up the reference of the hype cycle so I can remember what the things are called. There's the technology trigger, peak of inflated expectations. So we hit that like last year, or maybe like earlier last year. I think we're getting pretty close to like this trough of disillusionment. And this is why I'm like excited to talk about this stuff today, because about data mesh now, is because I think we're about to get on that slope of enlightenment portion of that, where you're not going all the way to the hype, of what everybody's saying, well, this could do. Now we actually can have like, I think, real conversations about this without it being conflated with vendor hype, right? So I think data mesh will also play a huge part in like how data virtualization becomes a reality and potential real thing that can happen.
So I suppose it sounds like virtualization is only, I guess, controversial to the vendors that want to lock you in to their centralized platforms. Is that what
Maybe.
you're saying?
I think to some degree, I think the ways in which I view the world with that anyways, my hope is that I don't want these vendors to ever go away either. Like, I think there's very valid use and I'm not going to, name names, but like, there are very, successful cloud data warehouses, right, that do really well with what they do, right? And so I don't think that that's a technology to be discounted. It's in fact, we definitely should include you. The thing I want to get away from is this whole, you have to move everything in on us for things to work well. Like, that sucks. And so that's always been like one of these like impediments to our entire, like, for the last, since data has really existed, we've had these problems of move everything into Oracle, now move everything into Postgres, now move everything into, or this version of Postgres, right? And it's just like that. Every time you have to migrate, every time you have to do this thing, it's like we're going in circles doing the same thing. You saw now with like, people kind of mass moving off Teradata these days, right? There's new products with Teradata, but I'm just saying, like, the old school warehouse version of it, people had to do some really tough migrations on that. There were a lot of interruptions. There were a lot of really long nights that some people had to sit through. So it's just like, if we're thinking about how to have true empathy for our data space, it's like, this is the real way forward for me in my head of having these capabilities.
How do we deal with, so I think this is a fantastic idea. Rewinding a bit, you were talking about the old school mentality, and I think we've been doing things that way since the 80s, right? Of like trying to lock people in, saying use Oracle or use Teradata, use this one tool to rule them all.
Oh, the 60s.
Probably the 60s, yeah, IBM going way back. No,
yeah.
That's fair. But I think the issue you run into often is that it's this death by 1,000 paper cuts problem, right? So for example, BigQuery and Snowflake both claim to be ANSI SQL. I think they're even certified, but they're definitely not compatible. If you sit down and try to run a Snowflake query on BigQuery and you're using any special features at all, it will not work. So how do we deal with those kinds of problems? Like, how do we somehow create an actual standard of SQL that's portable across in a virtualization layer, or how do we address that?
Yes. So there's always going to be, so with any standard, there's always going to be like part of the standard in ANSI is like you can be ANSI SQL compliant and you can have a whole definition of functions. So like look at Postgres, for instance. Like Postgres has a whole slew of they're ANSI SQL compliant, but then you look at like PostGIS, right? And that's a whole bunch of functions that don't exist in any other ANSI, or not. I mean, some do, but I'm sure a lot of people model off of PostGIS, but like one-to-one, it's like that's never going to happen. And so part of the ANSI SQL spec literally allows itself to be like non-generic. It allows itself to be, something that wouldn't move one-to-one. And so maybe, it would be ideal if we could structure the system to basically be like, if you are a vendor in the data space, we need to figure out a way to structure the system so that it's like puts a lot of pressure on them to be, to know this common set of maybe standard functions that we use, or what are basically, let's all as a community, as a data community, come together and find out like what are the things that typically trip people up when they're moving between SQL to SQL. Come out with like, hey, how do we standardize on even this, and maybe either add that into ANSI or try to get that into some other kind of like community driven thing of that's a little more flexible and pliable, right? But that's one just off the cuff thought there. But there's also, let's centralize on one thing. And so I'll go off my the place I just left from, right? So it's like working in the Trino community. So I still work in the Trino community, by the way. But so basically, if you have this translation layer that is, it's not storage at all. It's effectively something like Trino, where you have it's a query engine. It talks to all these different, it's able to do the translations from its version of SQL to all these other versions of SQL, to all these NoSQL databases, to all this data lake table stuff like Iceberg as well, and Delta Lake and Hootie and all that stuff. Can also talk to Snowflake. It also talk to BigQuery and all the data warehouses, right? So it talks across all of these things, and then you just need to know that version of Trino. That ANSI version of Trino's SQL, right? And that in itself, if you go to another, let's say you're on open source and you want to move to Starburst or you want to move to Athena, provided that they stay as close to that spec as possible, the spec being not just ANSI SQL, but Trino ANSI SQL, then that's going to make the moving between different query engines a lot more nice. And so this is like, you're still going to be locked into some degree, right? But you can't ever have it like to be perfect unless the SQL syntax is 100% the same. But you're at least not having to do the migration of the data. You're not having, you can really easily and cheaply pull up two versions of Trino side by side and move the connections underneath one Trino to another Trino, and whether that be Athena or Starburst Galaxy, and then address those slight variations there. Now, when you're moving between totally different systems like BigQuery, and you're moving between like, let's say move a BigQuery to a Snowflake or vice versa, then, you're 100% going to have to like copy the data 2 times. You're going to have to make sure that all of the same, and probably you'll do this a little bit by a little, like you'll take like some subset of one of your maybe lesser used data workflows and query, kind of sets of queries that you're running, and migrate a small set of data. And so you're copying that small set of data in the new one, and then you're still maintaining everything in the old one, and you're slowly basically having to do all this validation and testing that it works in the new one and producing the same answers and stuff like that as the old one. So that's much more difficult to actually get that copying of data. It takes much longer, and businesses don't move that slow. Usually they're more apt to go something a little more disruptive, right? To just be like, hey, we're going to cut this over. It's going to suck for a little while. We're letting all of our customers know. And then you're going to be working late nights for like the next 3 months. It's so like that's not fun. That's not nobody likes that. And whereas if you're doing this in a query federation layer, you're really just running two of the query federation layers. You're not having to move any data, and you're just repointing everything, right? So ideally, you don't even have to do that much either, right? You could even get to a point where you might have some way to be able to talk, like have one query federation layer to roll multiple query federation layers. And I've seen this done in Comcast and a couple other places, but it's interesting in other ways that you can keep abstracting the layers so that you never have to like affect the user. But anyways, I'm getting into a bit of a rabbit hole there.
Yeah, it's interesting. I mean, because I think there's this sort of competing notions between like centralization, vendors, and I guess whoa, Brian just left.
He may have lost his internet or something. We were having some internet.
Yeah, Brian has pretty crappy internet connection or something. So, well, it's a good internet connection from what he said in the stats there, but I don't know what happened there. Maybe just close the tab. Anyway, got any good jokes, Matt?
Didn't prepare any material.
No worries. No, there he is.
Fantastic, you're back. Okay.
Yeah, what I was saying is it feels like it's an interesting notion, right? Because we're trying to talk about a federation of data and unlocking ourselves from vendors. At the same time, I guess rallying the community around stuff that's not vendor driven or doesn't have some sort of a vendor element to it is I think a bit tricky, right? Even a lot of these popular open source projects are backed by vendors. I'm looking at Tabular. Tabular is a central table store for all your analytical data, and it's Iceberg. Right. Yeah. So it's this interesting notion where I think you bring up an interesting ideal that we should try and get to as an industry, compatibility of SQL dialects, for example, what Matt was indicating what we were talking about. But it seems like the industry gets in its own way a lot of times too, because we do have, I guess the community versus vendors versus, I just think a lot of opinions about how we should be doing things. And so, I mean, how do we get past this, Brian? I mean, in the next 5 minutes, explain how we overcome decades of issues and friction and troubles. Thank you.
The entire business model too, in some ways.
Yes, the entire business model. Yes, go for it. Thank you.
So, I mean, part of it is just getting people aware that this is possible, because like the only way to get any of this stuff like moving is to kind of make the public aware, right? And so. That's what I'm kind of doing here today. That's what I want to make my larger platform as I'm doing any of this stuff. I really think that if we have the full flexibility to move things around, we're going to have a lot better products, right? That come out of that because of the pressure that's put on vendors there. So how do we get there is like letting people know that this is even possible. And so and let me get into a little bit of a small bit about why people don't like virtualization and why it's such a dirty word that I think we need to fix. And I sent you all a blog that I'd like to share with everybody. Is by a professor from University of Maryland, Daniel Abadi. And so he's been really well known in the Hadoop space and stuff like that before. And so he's seen this all over the place. So yeah, thanks for posting that, Joe. So basically, the idea that data virtualization is just kind of like this niche technology that cropped up, I don't know, somewhere in the late 80s, early 90s. They tried it failed, and it's just, we should never try that again. It just doesn't make sense. It doesn't work. So this goes into a couple deals. And so I'll summarize the post for you a little bit. So Daniel kind of summarizes like four of these core concepts of why data virtualization is hard, and kind of talk about what's changed in to actually help us address it in today's cloud environments and what technology we have today. So the first thing he talks about is language translations. So obviously we've already talked about this a lot today already, is like, going from even an ANSI SQL compliant to an ANSI SQL compliant SQL, you're not going to have it be one-to-one. And so this already is, we're not going to beat this one to death too much, but it's pretty obvious. Like that's already a difficult thing of like, well, how do you, have something that's going to be the like thing that can talk to everything else. How do you send hints down to something that is like, you know, your version of ANSI SQL and transform that into their version of ANSI SQL. And so there's all sorts of ways to handle this. Sometimes there's these things called hints in SQL that you can just like, you know, send down like a little thing inside of a string, and that'll be tacked onto your SQL. And then that gets like actually run in the underlying system. But nowadays they have even these things called polymorphic or table functions, which are, you know, polymorphic table functions, which allow you to like run specifically like queries that, and this is implemented in Trino. So this is the example that's very fresh in my head, but you can basically run an exact query verbatim to the standard syntax of the underlying system. It doesn't even have to be SQL. It could be the query DSL for Elasticsearch. And you can send that down and actually have that specific query get nested within your larger SQL query, right? And that's actually just a table function, another table function that's in the ANSI SQL spec, right? That you can go ahead and do. So there's all sorts of ways around like dealing with the different language stuff. What's the best ways and what are the best practices? Like that's the things that as this data virtualization thing comes back to fruition, or comes back to like full throttle, I think that that's the part that's going to be very exciting to see, where a lot of the innovation goes to how do we make like one version of SQL or one query language to rule them all, right? But we never will. But I think that we can always talk about best practices, right? And best standards. So the next part that he says is an issue is having a query optimizer that has to run over other query optimizers. And so the other thing that's like kind of difficult is like you have this system now, this query federation layer that has to know about all the optimizations that all these other subsystems have underneath it, right? So it's like, how do you go about trying to like take advantage of some of the optimizations that Postgres has on the indexes that it has going on, right? It'd be a waste to just simply tell Postgres to do an entire scan of all its data and send that to the federation layer. So how do you kind of like intermingle the smarts of all these different systems and let the federation query layer know about all that?
Large language models.
Yes, absolutely. Yeah. So ChatGPT is going to be the answer to that one.
We'll optimize everything. Yep.
Yeah.
Might not. There might be a nugget of truth to that. Who knows?
Yeah. Auto cost-based optimization or something like that. Yeah. Mm-hmm. I mean, very possible. At this point, I'm not counting anything out. Let's see. And so then, the biggest thing I think that really like, I think this is the biggest one, is joining across tables that are in just different subsystems. So when you think about how this has been done, this has been really where a lot of the contention comes of like, how do we actually make data virtualization work? How do I join a table, over here with a table over here? And so the initial ways that people were doing this, so if you, I shouldn't mention names. So there are companies that are still doing this today, but the initial ways that people were kind of doing this was they would basically take a table. Let's say you have Postgres, and let's say you have like Oracle, right? You would take the data from Postgres and stream that data from Postgres to Oracle, and then perform the join in Oracle, and then return the results back to the federation layer. So the federation layer actually did not do any of the computations other than optimizing and trying to figure out what the plan was, tell the plan to basically say, hey, move this data between these subsystems and then like send the data back to me. Another smarter way to do that is, well, instead of having them send the entire table over, let's just send over the join columns and anything that's involved in like how we join this data. Let's move both of those over to the other table, filter those out, and then you take the resulting data set and then move that over. So at least you're doing some level of filtering beforehand, so you're not doing that heavy. So it's kind of a push down before of a query to both systems, and then you move the data over. So this was really the aim on the earlier iterations of data virtualization. And the main reason why this was the way that this was done is because networks were like increasingly slow back then. So it's the 90s. I don't know exactly what it would be in terms of the network speed, but let's say it was somewhere around like 512. No, maybe a little more than 512. It was 512 kilobyte per second. Is that a fair thing to say about the 90s?
I think it was like so fast Ethernet was kind of the thing, especially so like 10 megabits per second was a pretty common internet speed. And maybe when you got into commercial, you were getting into 100 typically. But like,
okay, my first
gigabit
modem was like
until like 2001. So sorry, too much detail.
No. And it's very relevant. I know that basically since the 1990s, we've basically like done 10x every year for the amount of networking speed that we've had. So that's a nice generalization of like how far we've come since the 90s. Like we're doing multi-gigabit per second. I think we're even at terabyte per second now in like in AWS and stuff. You can get all the way up to that, right? So like internet speeds have just like skyrocketed. And so that really changed how we need to address this problem of data virtualization. We shouldn't be necessarily thinking so much as we should always optimize for sending less data, but we shouldn't necessarily be thinking like of the network as a bottleneck anymore. In fact, it's really no longer the bottleneck in a lot of these things, even though we're dealing with, up to petabytes of data that we're scanning over. A lot of times we're not sending much more than gigabyte to maybe some terabyte, and terabyte per second. If you have that in your AWS VPN, as long as you keep those things co-located, it's going to be super fast. If you don't have them co-located, it's going to have a couple extra seconds, but it's not like insanely slow, that the things that they were optimizing for. So these systems that were trying to do everything not in its own layer, not doing the computation in its own federation layer, really missed out on a lot of optimizations that you can actually do when you take advantage the same way that these other systems were taking advantage. You still push down the queries to these local systems so that you're sending less data ultimately over the network, right? So if I'm talking to Postgres, I want to actually take the pieces of my larger query in the federation layer, and I want to like take some of those off and send that down to Postgres so that it does aware filter clauses, so that I'm getting way less rows, like effectively, ideally like a tenth of the data that it would have to send me if it was doing a full scan of that table, right? So I want to send way less amount and push as much down as I possibly can to optimize not only like the performance from the user's perspective, but just thinking about like eating up a lot less network, right? So you still do those same optimizations, but now you're doing the smart things that they were doing in the past, but you have your own layer that you can send the data to, pipe the data back to. And once you are piping that data back, you are now able to do the final bits of that processing in memory, streaming, not in the streaming like real-time type sense, but streaming in terms of like pipelining that data. And as it's coming in, you start to immediately do some computation on it. And so this is ultimately, where federation engines like Trino come in, as well as, I don't know as much about Dremio, but Dremio also kind of aims to do a lot of this query federation capabilities. And so, that's really where nowadays things have really changed. And what caused that change? Well, we moved to the cloud. With that move to the cloud, we didn't want to keep like our EC2 instances up like nonstop. So we wanted to be able to save data in a distributed manner. And so S3 came around, and S3 was literally this like separation of computation and storage, right? And once that set the stake in the ground of like, this is how we're doing things in the cloud, like everything had to optimize around it. And that's why we're seeing still like this huge cataclysmic rise of like how fast networks can be. And they're very reliable, right? So now that with these super fast networks, we've addressed a lot of the things from data of the issues that we had with data virtualization before. It now makes sense to have a query federation layer that can handle and do its own computations, because the systems that it can talk to and the actual computation layer are separated, just like they would be for S3 or just like they would be for a Postgres system sitting somewhere. So this is where it gets really interesting in that now you're addressing these old issues of data virtualization. It's just that nobody really knows about that yet. And let me see. And the final thing was, differing semantics in terms of how the data is actually stored. So if you look at like NoSQL versus SQL versus, there's a lot of weird stuff when you say NoSQL and you're applying SQL on top of that. I specifically did a lot of contribution to the Elasticsearch connector in the Trino side, and people, it's a very hard thing to think about. How do you add the SQL abstraction to query a NoSQL database? Because there's all sorts of things about like how there's implicitly no tables or indexes or things like that on this thing. It's actually, everything is just, one large chunk of data, and you're able to perform fast aggregations over that. But like actually being able to perform joins on, so for instance, if you connect to Mongo can't join between two collections. And if you connect Trino to it, now it can. if you needed to. So that's really, one of these interesting concepts about, how this query federation capability does eventually make sense. And if we can get more people to understand that, I know this is a long answer to your question of how do we make this happen, but getting people's minds to understand like that this is possible now, that data virtualization is no longer a dirty word, that it's like this really cool thing with a lot of potential to enable us to have a lot more leverage on, vendors that do want people to kind of get stuck in. I think we just need to get rid of that whole notion, and that's the way it has to be. And ideally we get people, once they realize this is the possibility, diving in and trialing, doing more of this stuff. At that point, it's no longer like, should I choose this or this, because it's going to be this horrible cataclysmic thing if I choose incorrectly. You're always going to choose incorrectly. Every software that you have is going to have some drawbacks to it. And so, where it's going to help in some use cases, it's not going to help in others. And this is why data virtualization is also so strong, is that you can, move wherever you need to move freely. And data virtualization enables you to literally just talk from that single pane of glass, and you're no longer having to like figure out, okay, how do I migrate in the future? Oh, how do I do this? No, everybody just talks to the exact same thing the entire time. So anyways, I'm going to stop there and see if there's any questions or see if there's any comment from y'all.
I think one concern I would have when I hear this, especially with the efficiency of the networks these days, is egress costs.
Yeah.
I think that's the cloud vendors are, they like to make their money, and one way they do that is by having the toll roads, typically out of their systems or between regions even. That's another one. Matt, you have
but they're one-way toll roads, which is a critical thing to think. Yeah. Meaning,
right.
It's really easy to get in. It's free to get in. It's expensive to get out.
Yep. And that
so you're still stuck with the centralization problem.
Yeah.
Well, that comes down to data modeling to some degree, but there's also solutions that vendors like Starburst. So one of the great things about Starburst, Athena is great if you're just hanging out inside of AWS all day, and then but Starburst on the other hand, like they're trying to figure out, well, how do we have this kind of like multi-cloud kind of setup where if you're talking to a data virtualization and let's say that's deployed in a Google Cloud platform, and then you're talking to another one in AWS, is there a way that we can actually, have yet again a virtualization to talk to multiple, basically a Trino that can talk to multiple Trinos, right? And enable us to be able to, query all of my data sets that are in AWS, all the data sets that are in GCP, and all the data sets that are in Azure. Because right now that's multi-cloud's getting a lot of flack because like people are like, well, that's just not the state. Everybody's like a good chunk of people are in AWS. And then also like, there's not too much fragmentation between individual companies. But I think that as just like with any technology, right, as we get more and more advanced in the cloud and moving things forward, and there's actually real competition that goes up against AWS over time, I think that it's only a matter of time before there's going to be a lot of splits into where people are actually located versus like, a good 80% of people are on AWS. So I think that that's another like thing that data virtualization can address, but then you have to start asking these like future questions that don't exist. As a huge problem today is, how do you manage that egress cost whenever you're doing queries across these things? And so, I mean, the way that people are typically looking at this right now is like, well, you gotta get really good at caching. You can also do a lot of like, this is one of the ways, but you could also literally just like, have 2 separate data sets for each one. But that sucks because you're paying for copies, and that's actually one of the great things that data virtualization can potentially avoid, is that if you're able to talk to Snowflake and you're able to talk to a data lake, you don't have to have copies of both of those things in Snowflake and the data lake to be able to take action on them. You could literally just like, you could have one in one and one in the other. If you need to use both, that federation layer lets you talk to both of those. And you use Snowflake whenever it makes sense for Snowflake, and you use the data lake for your like machine learning folks whenever that really makes sense to them. And I talked to multiple companies that have that particular setup, that they're trying to get rid of copying things. But I don't know. I don't have a great solution right now for when you're in multiple clouds, and other than just throw a caching layer in between it and do your best to like optimize that to where look at the way that your read access is going across these systems, and maybe there's a certain way to tweak it to where you lower it just to the right amount where you're going to pay that initial cost the first time on the egress fees, and then after that it's going to hit that caching layer, and that's something that vendors can build in and do a lot of like optimization around. It's definitely something that I froze for a second. Yeah, I froze for a second. Am I back?
You're coming
never
through.
left.
Yeah.
Yeah. Sorry, my computer froze for a second. Okay. So basically, yeah, it's effectively the caching for now, but maybe we'll as more people get into thinking in this space, right, there'll be better solutions.
I think there's probably a bridge between and I talked offline about this a couple months ago, but I think there's actually still some potential for WASM and maybe stuff like what MotherDuck's doing, or DuckDB and so forth, to sort of bridge the gap between whatever you have on your system, some virtualization, and then bring it at a local. Because the computers are so powerful. I'm trying to see if I want to pull the trigger on a M2 Max laptop, but I'm looking at this thing as like 30 core GPU, 12 core CPU. So that might be the kind of the way, at least bridge that gap. But egress fees, unless you want to go to Oracle and use their cloud, where you're going to pay maybe substantially lower egress fees. It's just sort of I kind of see egress fees though as like cell phone minutes back in the day. Like we talked about the 90s.
It's going to go away.
Like,
yeah,
maybe not though. It depends, because once somebody pulls a trigger, everyone else is going to follow suit. But it's sort of this standoff where nobody really wants to do that yet. So.
But Oracle is doing it, so if they're able to get a lot of customers that way, who knows? We'll see what happens.
Yeah, crazy things happen in this world. Actually, Lars, what's up, dude? He's got a question here. So he asks, how do you handle situations where you need to apply business logic before you're able to join different data sets? I have one example where I have to pack some time intervals into contiguous intervals. Then the join is defined by if those overlap with intervals in another data set.
So, there are. One way might be, it depends on exactly like what the size. There's a lot of depends in there, but let's just say there's a couple ways that you can approach it. So if you one way is that you could do like the step in 2 layers, right? You can first do one process where you're pulling data in, writing it out to like an external system. But you could also do like CTEs for that, right? So CTE basically saying with this, you define your first set of data that's being pulled out of that subsystem. Ideally, again, that's going to be where it depends. Like, do you have some filtering clauses that could potentially be pushed down to that data set? You want to make sure that you're optimizing so that if you're doing a CTE and then you're doing stuff later, that you're trying to get as many filters and as many like things that can push down and ultimately speed up the query as you can. So trying to set it up in that way, but if like at the end of the day, the query is the way the query is. And so like, if you have to, do a first initial scan, with the CTE, maybe putting some sort of business logic that cuts it down first, and then pull it out. Because ultimately, if there's, let's say there's a business logic where there's like you set up some case statement, and then from there you have to shape the data in a particular way. That as well may not be pushed down, something that can get pushed down in the engine, but then like that's something that you can actually work with the like community to get implemented, or with whether it be Dremio or whether it be Trino and Athena. And the great thing is, like, if you do it in one of these like things in the open source side, this trickles out to what's capable in all of the other engines and all the vendors that implement them, right? So let's say that case statement, right? Let's say I think actually it should get pushed down. Let's say if it was like to Postgres. So you're going to push that down actually, and it's going to be, case statement gets pushed down directly into Postgres. That gets pulled back in that particular data set, and that's the full data set. Then you perform that join. Now, maybe there's a way where you can intelligently figure out, this could also be something that the cost-based optimizer could do at some point, but like the cost-based optimizer might even be able to look ahead and say, hey, once we get this data back, there's also this other filter that we can apply afterwards, which is going to only return the rows that are applicable to the join. But that's what's possible. That's not necessarily like what's done. And again, that's going to be like when you're talking to these federation layer systems, it's going to be based on the connector, the specific connector that you're talking to. So,
yeah, I'm curious what the intersection is too of like maybe semantic layers with a virtualization or federated type queries like this too. So, but there's a lot of details in there that need to be worked out.
I think semantic layers are trying to go a little step higher. I still think that there's some overlap in what they're doing. But I really think like federation layers are more looking at core database systems and how to optimize speeds. Semantic layers are more conceptual and making things more approachable to users.
Well, this ties back to what Lars was asking though about the business logic, right? So you have different data sets, perhaps unknown sources, right?
Yeah.
The business logic is the overriding thing. I think that's what he's getting at. Is the implementation details shouldn't necessarily matter. Lars, correct me if I'm wrong on this, but that's something I've been thinking a lot about too, is, having overarching business definitions and logic, and then the implementation details of where you get the data that's a separate concern, because at the end of the day, business logic is business logic, right? It should not have to depend on the implementation details. So that's where maybe a semantic layer or some variation of that happens. I don't know. All this is TBD.
So. Yeah, I mean, go ahead.
Oh, what I was going to say, though, is I think part of what we're alluding to is that there are a lot of things that vendors could do and that we can do as a community technologically to make this work better. But how do we incentivize that? Like, how do we incentivize Snowflake and BigQuery and Databricks and everyone else to play nicer together to make this a lot easier for the users and for people building virtualization layers?
I mean, standards, right? We got to get standards, and we have to get people we got to get customers really demanding and pushing those standards, right? Because I think that once it becomes something that the community wants, once it becomes something that, and enough of the community has to be like a large consensus, and it has to get to the point. So, I mean, I'll say this, like I was excited, but very surprised to see that when Snowflake implemented the Iceberg integration, which was like, it seemed very anti-Snowflake, but at the same time, then it made total sense. I was like, well, yeah, they realized to some degree they can't just be that all-in-on-one narrative, because if you do that all the way, then people are gonna realize that and then leave, right? So now they're kind of they're dipping their toe in the water of federation. They still want it to be going through Snowflake channels, but it's still this pressure that was put onto them to even do this in the first place, and it's incredible that they're getting to this point. Now, you can think we could sit there and think about what their actual motivations are for that, but I really do think that's who cares what their motivations are. Like if they're actually doing it, it's helpful for the community in general to have those options, right?
It's interesting. Santona, she's going to be on the show next week. Hi. She has a quasi question. A federation layer doesn't have to come at the price of excluding parameterization and dynamic filters and repartitions, right?
Absolutely not. And it really, this comes, when you're at a federation level, right? This will always, like, the interactions that you can do at that query federation level is always dependent on like how you've implemented the specific code that interacts with the federation layer and the actual underlying data source. And so anything that's capable is going through that federation layer has to be implemented in that connector. And so basically, if you want to take advantage of any of the existing capabilities, you have to bring that up to the community and say, hey, I just tried to do this. Is this possible? Or you look at the documentation or something like that, and oh no, we haven't implemented that yet. Let's get together and work on the spec for this and how this, how we're supposed to be able to send down parameters and dynamic filters and things. And so this is actually implemented in the S3 setups and Trino, being able to do dynamic partitions and things like that. So that's very possible. But is it implemented in every single thing you're connecting to? No. And so like, that's where it's going to start coming into, like, you have to look at your own specific use cases, find out where you're hitting the barriers. And collectively, if we come together as a community and really come around and make a standard around this, it doesn't have to be just Trino or just Dremio or any of these things, right? Let's figure out how do we agree as a community that this function should be done, and I don't know if I'm not going to be the one totally leading this particular charge yet, or maybe I will one day, but like, it would be like, how do we come up with a more flexible spec that kind of evolves with the community needs? That isn't basically saying that isn't as slow as ANSI, right? But that is basically something that could be a little more pliable, that we start putting pressure on vendors to say, hey, like, this should be what we expect you to have. And if you're not community SQL, 252, compliant, then I'm going to move on to another thing. And once that happens, there's a lot that's how you start to drive this incentivization. And you start to really, kind of enable this kind of movement towards empowering people to, ask what they want, versus feeling like this sense of like, I'm stuck to whatever this vendor has to me now. They have me chained with this data, right? So you do have the capabilities. It's just not always like immediately baked in. That's the answer to Satona's question.
Cool. Awesome. I think we're coming up on time. Thanks, Brian. Thank you for the nice clinic on virtualization. It's a really good chat. I'm very curious to see where this goes, especially with respect to data mesh and data products, so to speak, and things we didn't get to talk about, but we can have another episode to talk about it. So it's
sure. Yeah, I know. This is actually the thing that we were supposed to talk about this time, but
we got sidetracked.
We did get sidetracked. Yeah. So
these are conversations that I don't hear a lot about virtualization either, to be frank. I think in a lot of cases it's the data mesh conversations that come up, and I think that those are probably worthy of a separate discussion, like I said, because there's a whole other universe or a can of worms to unpack.
I'll give the quick nutshell version of that. So of the 4 principles, right, that Zhamak laid out, 3 of them get pretty much solved with data virtualization, and along with like a couple of the catalog services like Amundsen and stuff. And then you have the 4th one, which is the federated computational governance. And that is the piece that actually allows you to take social policy, spoken policy that we say that we agree upon, and codify it into some sort of configuration layer, like we did with Kubernetes, right? Hey, Kubernetes, we did that for the service layer. I want to have this many instances up and blah, blah, blah. We need to do the same thing for the data layer. And ultimately, federated computational governance can basically be the Kubernetes on data, on how you set your policies for data. And when we have a meeting, we can actually specify an actual spec that says, hey, this is what came out of this meeting. We want to update the spec to be this, and this. It's versioned. It falls into all the other things we've done for every other ops layer, right? So we need to do this for data as well. And that's kind of, go ahead.
Yeah. Well, I mean, it goes back to sort of the business logic question that Lars
Yep.
had earlier too, like that.
Yeah.
Yeah, and that's like I said, that's the one that doesn't exist really yet, and I think it's also the hardest one.
Yeah.
Because you're getting into the realm of people and all their problems.
Yeah.
So it's super fun.
We'll just throw it. We'll throw it to ChatGPT and it'll take care of it.
That's right. No, but it's almost like we need a CNCF, like a cloud native computing foundations for data, to like set standards as a community from a bunch of big participants, not just vendors, but also companies that use data. Anyone who cares about this issue can come in and have a say. But that's where it gets complicated. To your point, Joe, like the human issue is always what trips up these efforts.
I have a lot of opinions on this, so happy to talk about this in another one.
Yeah, we'll make that a deal. Well, cool. Yeah, wrapping it up here. For people who want to learn more about you, how can they do that?
So I'm a Bits on Data Dev is like my handle for everything across. So you can. I have most people are watching this through LinkedIn. So just follow me / connect with me on LinkedIn, and that's one good way to get started. I push a lot of my stuff through there. I'm also on Twitter, and I did try out Mastodon, but I got off of it. I haven't been doing it lately. Yeah, and that's just reach out to me if you have questions about this. Really want to start seeing if there's some ideas around how do we get the community really involved in pushing this data virtualization concept further, and also, and that goes into other things like cloud data lake houses and stuff like that. So
awesome. Cool. Upcoming events. Utah Data Engineering Meetup. If you happen to be in Utah, come to our event on Wednesday, the 17th. It was Imply, Decodable, doing a real-time workshop. So that's going to be pretty dope. Let me see. Next Tuesday, I'm doing an event with Bill Inman on, what is that, May 22nd. So we talk about data architecture, data engineering, data lineage. I think Robert Scott's also presenting there. So that's going to be cool. And then what else? I'm doing a talk with SoftServe, a fundraiser for Ukraine on Thursday, the 24th. So that's pretty cool. And I don't know, Matt, do you have any events coming up?
Not in the real near future. Yeah, hopefully I'll have some things to announce next week.
Ethan's Happy Hour, is that happening soon?
I think that's on June 1st, but I probably won't be in town there. But yeah, if you're interested if you're in the New York City area or going to be in the New York City area on June 1st, then reach out to Ethan Aaron about his happy hour. Really great place to connect with data people in the New York City data scene, and also people from all over the place, just because people come through here frequently.
New York. Yeah.
Can I also push in an event?
Yeah.
So Trino Fest is a virtual event that's going to be June 14th and June 15th. It's a 2-day event. And so just go to trino.io. Their little banner to sign up for that stuff is gone through there right now. And let me know if you have any questions. I think we just closed the call for speakers last Friday, unfortunately. So
it happens.
Yeah, it does happen.
Yeah. Let me see. Yeah, I think that's about it. So we got Santona Tully on the show next week. That's going to be great. I'm not sure if we're going to do a show for Memorial Day, Matt. I think we just need to flip a coin or decide if we want to do that or not. So
try to decide. Yeah,
we'll have a grand total of 2 people showing up, so that'll be great.
I mean, everyone likes to spend their day off with us, right?
Of course. It's what better way to spend your time. Awesome. Well, cool. Brian, it's been a pleasure to have you on the show. And,
great being here. Thanks again.
Yeah. And for the audience, this is also available as a podcast. In case you didn't know, you can find it on all major podcast platforms. So stay tuned for that. Oh, and by the way, I have a new newsletter coming out on Friday. So there's that on Substack.
Nice.
Go to joereese@substack.com. Check it out. And alrighty. Have fun, everybody. See ya.
See ya.